right, so we're diving into dependency injection and C# today.
Yeah, looks like we've got a ton of notes and articles here.
We do. It's a pretty hefty stack, but, whether someone's getting ready for a meeting or maybe just trying to, brush up for a project.
Or just curious about this whole DI thing.
Exactly, exactly. We're going to try to pull out the most useful, coolest stuff from all this information.
And you don't have to be a coding expert to follow along.
No, absolutely not.
We want to make sure that everyone gets those light bulb moments, where it suddenly clicks even if the concept seems complicated.
Exactly, exactly.
Yeah.
It's like when you order a latte at a coffee shop, you don't really think about grinding the beans or frothing the milk or anything like that.
Right.
You just tell the barista, hey, I want a latte, and they handle all those, dependencies for you.
I like that analogy.
So dependency injection, or DI as we like to call it.
Yeah.
It's kind of like that. It's like that for software.
Yeah, it's a great analogy because it really highlights that idea of inversion of control, which is really at the heart of DI.
Right.
So, imagine your code needs a database connection, right? Instead of your code saying, go create a database connection, DI flips the script.
Okay.
It says, hey, here's the connection you need. Use this. So someone else is handling that complex setup. It's taken care of for you.
So it's like outsourcing the hard parts to a super efficient barista, basically.
Exactly.
Yeah, I'm starting to see why people like this.
Yeah.
So our notes mentioned 3 main types of dependency injection.
Okay.
Constructor, property, and method injection.
Yep.
So it sounds like there are a few different options for how we can serve up those dependencies to our code.
You got it. And just like a coffee menu, each injections type is going to be suited for different situations.
Okay.
Let's start with constructor injection. Think of it like ordering a classic latte. All the essential ingredients, the espresso, the milk, maybe a flavor shot.
Yeah.
Those are specified upfront when you place your order.
Okay.
So in code, this means the dependencies are provided when the object is first created right through the class's constructor.
Okay, so constructor injection is for the must-haves.
Yep.
But what if a dependency isn't, totally essential? Like adding whipped cream, it's nice to have, but it's not a deal breaker.
Right. That's how property injection comes in.
Okay.
Think of it like adding a sprinkle of cinnamon on top of your latte after it's already made.
Right.
So dependencies are provided through public properties of the class, meaning they can be set or changed even after the object is created.
So it gives you more flexibility.
Exactly, more flexibility.
So if constructor injection is for building the core latte, property injection is for those optional extras?
Yeah.
So when would I choose one over the other?
That's a great question.
Yeah.
Think of it this way. If you're building a car in code, the engine is a mandatory dependency.
Right.
No engine, no car.
Right.
You would use constructor injection to make sure that that engine is provided when the car object is created.
Okay.
But something like a sunroof, that's a nice to have. It's a feature.
Right.
Property injection gives you the option to add it or leave it out.
I see. So it's about choosing the right tool for the job based on how essential that dependency is.
Exactly.
Okay, so what about method injection? Our notes mentioned that one. It seems like it's for very specific needs.
Right. Method injection is about passing dependencies directly into the methods that need them. So think of it like adding a shot of caramel only to a specific drink.
Okay.
You only need that caramel for that one drink. You don't need it for every order.
Yeah, that makes sense.
Yep.
So if our car, needed a special tool for a specific repair, we'd use method injection to provide that tool only when that repair method is called.
Exactly.
It's like saying, hey, I only need this special wrench for this job, not every time I work on the car.
Exactly. You got it.
Cool.
And understanding these nuances is really what helps developers write cleaner, more maintainable code.
Okay, cool. So we've got our menu of injection types, but those are just tools, right?
Right.
The real magic happens when we see how DI is actually used in building software.
Yeah.
So what are some situations where DI really shines? Where does it really make a difference?
Well, one area where DI really shines is service configuration.
Okay.
Yeah, it's like the behind-the-scenes magic that makes your favorite apps work smoothly.
Okay.
Think about all the complex components in a typical app like database connections, logging systems, or external APIs.
Right.
DI helps manage all of that.
So instead of having this tangled mess of code trying to set everything up, DI provides a more organized way to handle those services.
Exactly. With DI, you register your services and their implementations with what's called an IOC container.
Okay.
You can think of the IOC container like a behind-the-scenes manager that hands each part of your code exactly what it needs to work.
Gotcha.
This container then injects the right dependencies where they're needed so you don't have to wire everything up manually.
Oh, so it's like having a designated setup crew that makes sure everything is in place before the show starts.
Yeah, exactly.
Yeah, no more scrambling around at the last minute.
Yeah.
So what else can DI do for us?
Well, it's also a game changer for decoupling modules within an application.
Okay.
Remember our coffee shop analogy?
Yeah.
Imagine the shop has different modules, an espresso machine, a milk frother, a syrup station, and so on.
Right.
Each module focuses on its specific task, and they don't need to know the inner workings of the others.
Right. So it's like having a team of specialists who are experts in their own areas. The
Exactly.
barista doesn't need to know how to fix the espresso machine. They just need to know how to use it.
Precisely. And DI allows these modules to interact through interfaces or abstractions rather than concrete implementations.
Okay.
This means you can easily swap out modules, update components, or even introduce new features without breaking everything else.
Yeah, this is huge for developers because it means you can update one part of your app without causing a chain reaction of errors.
Right.
Way less stress.
Yes.
So it's like being able to upgrade the espresso machine without shutting down the entire coffee shop.
Exactly. You can improve individual parts of your application without disrupting the whole system.
Cool.
Yeah, this flexibility is a major advantage of DI.
Okay, so DI helps with service configuration and decoupling modules.
Mm-hmm.
Anything else? Our notes mention testing, but I'm not sure I get how DI makes testing easier.
Great question. Remember how we talked about replacing espresso with decaf to test a specific scenario?
Yeah.
DI lets us do something similar in code.
Okay.
We can swap out real dependencies with what are called mock objects.
Okay.
These are basically test doubles that simulate the behavior of real components.
So it's like having a stunt double for a dangerous scene in a movie.
Yeah,
You can test the action sequence without risking the real actor.
exactly.
But how does that work with code?
So think of it this way. Imagine you're testing a piece of code that sends an email.
Okay.
You don't want to actually send real emails every time you run your tests.
Right.
That would be messy and inefficient.
Yeah.
With DI, you can inject a mock email service that simulates that sending process without actually sending anything.
Ah, I see. So you can isolate the specific code you're testing and make sure it works as expected without worrying about the complexities of actually sending emails.
Exactly.
Okay, that makes a lot of sense. So to recap, we've seen how DI helps with service configuration, decoupling modules, and testing.
Yep.
Is there anything else?
Well, those are some of the main uses, but the real power of DI lies in the benefits it brings to software development as a whole.
Okay, I'm ready for the big reveal. What are these amazing benefits that make DI worth the effort? Give us the cheat sheet.
All right, buckle up. Okay, here's the rundown of the benefits.
All right, lay it on me.
First up, loose coupling.
Okay.
We've already touched on this, but it's worth reiterating.
Right.
Components in a DI system depend on abstractions rather than concrete implementations,
Okay.
making it easy to swap out parts or adapt to changes without breaking the entire system.
Okay.
Think of it like being able to easily change the battery in your phone.
Right, or like being able to switch between different brands of coffee beans without needing to buy a whole new coffee maker.
Exactly.
Flexibility is key.
Yes, flexibility is key.
What else we got?
We've also seen how DI enhances testability.
Right.
By injecting mock dependencies, we can isolate components and write more focused and reliable tests.
Right.
It's like using that decaf espresso.
Yeah.
You can test specific parts of your coffee making process without the caffeine jitters.
Right. As long as you don't accidentally give the decaf to a developer who needs their caffeine fix.
Right, exactly.
That could be disastrous.
Yes, that would be bad.
But I get it. DI gives you more control and precision in your testing.
Exactly.
What about the long-term effects of using DI? Does it make code easier to manage down the road?
Absolutely. DI significantly improves maintainability.
Okay.
Think about making changes to a large code base.
Mm-hmm.
If you need to update a dependency, like switching to a new database,
Right.
DI makes that process much smoother.
Okay.
You only need to change the configuration in one central location rather than hunting down and changing every single reference throughout your code.
So it's like having a master control panel where you can easily tweak settings without having to rewire the entire system.
Exactly. DI simplifies maintenance and reduces the risk of introducing errors when making changes.
Gotcha.
It's a huge win for developers working on large, complex projects.
Cool. It sounds like DI really helps with keeping things organized and under control.
Yes, definitely.
What other benefits are there? Our notes mentioned reusability, but I'm not sure I understand how that ties into DI.
Good point. Reusability is another major advantage.
Okay.
With DI, components become more modular and self-contained, like Lego blocks.
Right.
You can assemble them in different ways to build different features or even entire applications.
Wow.
This promotes code reuse, saving time and effort in the long run.
So it's like having a collection of pre-built, well-tested components that you can easily plug and play into different projects.
Exactly. It's like having a library of reusable building blocks that you can mix and match to create different structures.
Yeah, that sounds incredibly efficient.
Yes, it is.
Like having a toolbox full of specialized tools that you can use for a variety of tasks.
Exactly.
Okay, so what else is in this DI toolbox?
Last but not least, we have centralized configuration.
Okay,
With a DI container, all your dependencies and their configurations live in one place.
gotcha.
This makes it easier to understand how your application is structured, manage dependencies, and ensure consistency.
Okay.
Think of it like a well-organized blueprint that shows you exactly how everything fits together.
So instead of having configuration scattered all over the place, it's all neatly organized in one central location.
Exactly.
That sounds like a dream for anyone who's ever had to dig through a messy code base.
It is. It really is.
Wow, we've covered a lot of ground here.
We have.
It seems like DI really is a game changer for software development, offering benefits like loose coupling, enhanced testability, improved maintainability, reusability, and centralized configuration.
It's a powerful tool.
It is, it sounds like it.
Yeah.
So as we wrap up, for anyone listening who's, intrigued by all this and wants to explore dependency injection further, what's like the one key takeaway they should remember?
I would say the most important thing is to understand that dependency injection is a design pattern that helps you write better, more maintainable code.
Okay?
It's not a magic bullet that solves every problem,
Right?
but it's a powerful tool that can significantly improve your development process.
Awesome. Any last words of wisdom before we sign off?
Just remember, like any tool, it's best used with careful consideration and a touch of moderation.
Great point.
Yeah.
So as you continue your coding journey, remember, dependency injection is a powerful ally, but, like with anything, moderation is key.
Absolutely.
And never underestimate the power of a well-crafted latte.
Well said.
That wraps up our deep dive into dependency injection in C#.
Yeah.
We hope you've gained some valuable insights and feel inspired to explore this design pattern further.
I hope so.
Until next time, happy coding.